Well, I unintentionally stopped my last recording. So you have a whole separate video on the new part about systems of three equations. What can I say? So, if you don't have your notes yet, you may want to pause this so you can write some things down. We will be finding three values. These problems can be much more difficult than the problems I am choosing to assign to you. They can get very complex, but we will be delving into them on a level that is, I think, a little more manageable. So here's my system of three equations, and I want to try to put things together two at a time. Don't try to put everything together at once. If I can put things together two at a time so that one or more of the variables eliminate, that's what I want to do. If two of them can eliminate at once, that is fantastic, because then I can find a number value for one of the variables. Oftentimes this doesn't happen, but in this particular problem, there's a couple things that happen pretty easily. Just remember, you do not want to try to put them all together at once. So in this case, we're going to take these first two and group them together. We're going to add those two together. So I'm going to rewrite it over here. You might be able to do this without rewriting it, and that is awesome and great, but just so that we're all aware of what's going on and no one's left scratching their head about what's happening. I hope it will be helpful for me to have written it out. So if I put those two lines together, my x's eliminate, and by Jove, my z's also eliminate. My y's, I have 6y, negative 10 and negative 8 is negative 18. So this is makes this process so much easier, because we are going to be able to divide by 6 and already know that y is negative 3. Now I might look at my other equation, and again, you can pick any two equations to put together. So let's say, for instance, now I say, okay, what if I try to include the bottom equation and the middle equation? And think, why would I want to put those two together? Yeah, again, I see the z's cancel, and this time the y's also cancel. So I'm going to rewrite that, although since it's right there on top of each other, my instinct would have just been to put it there, but I'm going to go ahead and rewrite it. Oops, except that's not a plus. Minus y plus 5z is negative 17. So when I put those two together, the z's cancel, the y's cancel. We have negative 5x is equal to negative 25. When we divide by negative 5, we get x is 5. Once we know two of the values, we don't need to keep putting things together. Once we know two of the values, we can plug those two values into any one of the three equations and figure out the third value. So that's where we're at here. So we're going to say, I'm just going to take that first equation, 2 times 5, because that's my x, plus 5 times negative 3, that's my y. We don't know z, that's the guy we're still trying to figure out, is equal to negative 10. So 2 times 5 is 10. 5 times negative 3, negative 15, or you could put plus negative 15, plus 5z is negative 10. Combine these two like terms, so that's negative 5 plus 5z is negative 10. Now let's just solve for z. Add 5 to both sides. Divide by 5. And I get z is -1. So now I have a value for x, y, and z. And then remember, you can always test it. You don't have to test it in every single equation, but especially since it's a new process, probably a good idea to test it in at least one of the other equations. So let's test those 3 numbers in the second equation. So I'm going to do -2 times 5 plus -3, because that's y, minus 5 times -1, and I should get -8. So this gives me -10 plus -3 plus 5. So -10 and -3, -13 plus 5, ding, 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 does give me -8. And then we write the answer as an ordered triple. So instead of an ordered pair, it's an ordered triple. X, Y, Z, alphabetical order. So this is going to be 5, -3, -1 in alphabetical order. And there's my ordered triple. All right. I know, it's very busy. It's very busy. That's why I gave you lots of space, so you can space those things out. I just tried to keep it all on the same screen. May or may not have been a good plan, but hopefully with the use of color, you were able to follow along with each of the steps. So once we know 2 of the values, we can choose any of the 3 equations to plug into to find the third one. So that one, honestly, most systems of 3 do not turn out quite that easily, where we have 2 things cancel so easily. So let's look at another example. Okay, I tried to find a way that this was going to give us a little more of the screen, and I'm not really sure that it does, but I tried. So this is focus question 6, because the focus questions were numbered starting with the systems of 2. So that's why it's number 6. So now again, let's think, is there something that could cancel out if I added 2 of the 3 equations together? So take a quick look at the problem, because if I can eliminate one of them, that's going to get us heading in the right direction. So hopefully you recognize that these 2, the x's, could get eliminated. So we're going to put those 2 together. That's going to be my step 1. I'm going to put those 2 together. And again, you might be able to successfully do that without rewriting. Honestly, sometimes I'm afraid I'll rewrite it and copy something wrong. But those are my x's. They're gone. 6y and -4y. I have 2y. 4z and 1z make 5z. 26 and -8 is 18. Now you might say, but that doesn't help me because that doesn't, I still don't know a variable. Well, you're right. This is how it's more typical what happens. So now let's think about, now we haven't used that final equation yet. Now what we're going to do is we're going to take this third equation. Notice it only has y's and z's, and we're going to put it with the result of putting those first 2 together. So that's going to be our step 2. I'm going to move it over to the left. So we're going to take this -2y plus 5z is 22, and we're going to put that with what we got from those first 2 combined. And in this case, now we behave like it's a system of two equations. That's going to allow us to find the z and the y, and then once we have two, we can go back to one of the original equations to find the third one. In this case, it's very nice and neat because these are already opposites. If they weren't already opposites, I could multiply one line just like we did with systems of two. So this becomes 10z is equal to 40. We divide both sides by 10, and then we find that z is equal to 4. So I have one variable. Now, don't try to rush back and take that to one of the big equations. Take it back to one of those two that we just worked with. So I'm going to take that piece of the answer, and I'm going to take that, and I'm going to plug it in to this. So that's going to be my step 3. Negative 2y plus 5 times 4 is equal to 22. So I just take it back to either of these two that I just used. Don't take it back to one of those ones with 3. It's not really going to be helpful there yet. So negative 2y plus 20 is 22. 5 times 4 is 20. Now solve for y, two-step equation, subtract 20. Divide by negative 2. So y is negative 1. Now that we have 2 of the 3 parts, now I can take those 2 parts back to the top equation, or the second one, to find out what x is. So my step 4 here is going to be negative 4x plus 6 times negative 1 plus 4 times 4, since that's what z is equal to 26. I'm going to do a little adjusting here. So my y was negative 1. I'm going to move that up there so we have a little clear space down here. So this was 4 times 4 is equal to 26. So that's negative 4x minus 6 plus 16 is 26. So negative 4x plus 10 is 26. Subtract 10, negative 4x is 16. Divide by negative 4, and x is negative 4. And then you know it, I would put all 3 of them in to the second equation, not the very first one that I just used, but to the second equation to make sure it works. So 4, this is my check, 4 times negative 4 minus 4 times negative 1 plus z, which is 4, lots of 4's here, should be equal to negative 8. So this is negative 16 plus 4 should equal negative 8. So does it? It does. So I'm satisfied with my answer. This is 5, me doing the check. In this case, step 5. So my final part of the question is to arrange my answer x, y, z as an ordered triple. Yep, that's a whole lot going on there. Okay, a whole lot going on there. So I put the first two together to make one equation with two variables. I used that one and the last equation as a system of two. That allowed me to find y and z. Once I knew y and z, I could go back and find x. Then I checked it by plugging in all three values to make sure that it's true. You could double check by plugging into every single one of them to make sure that it's true. But a system of three equations, those values need to work for all three equations. Your assignment is going to be posted on Google Classroom, and you should get the first two right. But as you're doing that assignment, you are going to be asked to give your solutions in ordered pairs. And you're also going to be asked to fill in a box telling how you got your answer. Okay, so not for the first two because they are ready to eliminate immediately, but you will be asked to explain part of your process in problems 3 through 8. That is for your system of equations part 1. There will be a second one for part 2. Again, that will be posted in Google Classroom with a link to take you to the teacher-made program where you'll be able to type in your answers. I do not expect that you show me every bit of your work. The smaller box is just for your ordered pair answer. The box that has a prompt in it saying to tell me what you did is where you're going to type in some explanation. Again, I do not expect or want all of your work to be typed. I want things like, I multiplied the second equation by 3, or I multiplied the top equation by -1. Please ask if you are uncertain of how to proceed.